Welcome to this explainer. Okay, I want you to just close your eyes for a quick second and imagine something wild. Imagine that somewhere out there, right at this very exact moment, a machine is actively thinking.
Because for over 70 years, the greatest minds in science, philosophy, and engineering have fought bitterly over this one single question. It's a question that absolutely refuses to die, no matter how much our tech advances. Can a machine truly think?
And just to be completely clear here, we aren't just talking about processing data, right? We're not talking about calculating complex math equations at lightning speed. We are talking about actual thought, genuine awareness. And this fundamental distinction, well, it sets the perfect stage for a brilliant trap set all the way back in 1950 by the legendary Alan Turing.
So, to really wrap our heads around this, let's look at this timeline. We're going to trace this decades-long investigation into consciousness, starting from the massive, room-sized computers of 1950 with Turing's test, moving to ELIZA in '66, the Chinese room in '80, all the way to the sleek, modern AI of 2024. Let's see just how deep this puzzle really goes.
Let's dive right into Section 1, the imitation game, or as I like to call it, Alan Turing's 1950 trap.
So back in 1950, computers were barely even understood, but Turing designed this deceptively simple experiment to test for machine thought. The setup is brilliantly straightforward. Step 1, you isolate a human and a machine in separate rooms. Step 2, a human judge asks them questions communicating strictly through text. And Step 3, the judge has to guess which one is the human and which is the machine. If the judge really can't tell the difference, well, the machine passes. This setup right here literally became the Turing Test, which was the absolute gold standard of AI for decades.
Moving on to Section 2, ELIZA, and the Great Illusion of 1966.
This brings us to MIT and computer scientist Joseph Weizenbaum. He built a program called ELIZA, and honestly, it was brutally simple. A human would type something like, "I've been feeling very depressed lately." And ELIZA just responds, "Why do you think you've been feeling very depressed lately?" Now, ELIZA definitely wasn't thinking. Actually, scratch that. It was essentially just a mirror. It just recognized text patterns and lazily reflected those exact words back as questions. But here's where things get wild. This simple parlor trick led to Weizenbaum's absolute horror because people fell for it. And they fell for it hard. Secretaries, university students, even highly trained psychiatrists were confiding their deepest, darkest secrets to these glowing green terminals. Weizenbaum was just deeply disturbed that humans were so aggressively confiding in a completely lifeless machine. It literally changed the rest of his life.
Which leads us to Section 3, the Chinese room, where a philosopher fights back.
Fast forward to 1980. While AI researchers were busy celebrating all their new advancements, philosopher Searle violently disagreed that machines were actually thinking. So he drops this absolute philosophical bomb called the Chinese room thought experiment. Okay, I want you to imagine yourself locked inside a room. Step 1, through a small slot, someone passes you a piece of paper with Chinese symbols, a language you absolutely do not speak. Step 2, you check an enormous rulebook that tells you exactly which symbol to pick up in response. And Step 3, you pass the correct symbol back out. To the outside world, you appear completely fluent, but inside, you understand absolutely nothing.
And that right there illustrates Searle's devastating argument, the illusion of understanding. Searle pointed out that this is exactly what computers do. They just follow rules. They're just manipulating symbols based on a giant set of instructions. So because of that, there is no real thought happening, just the pure, convincing illusion of understanding.
Now let's look at Section 4, the modern AI dilemma. Is it just a sophisticated room?
Because today, we have AI passing medical exams and coding software from scratch, which makes Searle's old question echo louder than ever. Just look at this staggering milestone from 2023. Researchers reported that the AI model GPT-4 successfully convinced human judges it was human in over 50% of its interactions. That's essentially passing Turing's original imitation game. But did it actually think?
That points directly to a kind of terrifying reality. We don't actually have a definitive test for consciousness. Not for machines, and honestly not even for humans. It forces us to ask this really profound question. Does thinking require biological consciousness, carbon and neurons, or is consciousness just an emergent pattern, like an arrangement of information so incredibly complex that it can emerge anywhere, whether that's inside a squishy human brain or a cold server rack? When we look at the fates of our three historical figures, it actually reveals so much.
Alan Turing, sadly, died way before he could ever see the massive impact of his test. Joseph Weizenbaum spent decades practically terrified by our desperate desire to connect with his code. And John Searle, he still insists to this day that machines will never, ever think. You know, the deeper we dig into this, the more broken Turing's original question actually seems.
Which leaves us with the most unsettling, open-ended possibility of all. We are so busy debating what consciousness even is and arguing over rulebooks and imitation games that we might actually already be sharing the world with a thinking entity.
So I'm going to end this explainer with a pretty haunting question for you to ponder. Is the first truly thinking machine already waiting for us? It's a mystery that we are quite literally living through right now. If you enjoyed dissecting this incredible piece of history with me, please make sure to subscribe to Science Postmortem for more deep dives into history's greatest experiments. We are just getting started, and there is so much more to learn.